So if you are a 9th grader in this class, you would have did the Pythagorean theorem in 7th grade accelerated. If you are a 10th or an 11th grader in this class, then you would have learned this in 8th grade pre-algebra. So this should be a refresher for most of you. There's always a couple people that say they've never learned it before, and I'm like, yeah, okay. But anyways, so the Pythagorean theorem. It's used to find the missing sides of a right triangle. So you can only use the Pythagorean theorem for a right triangle only. So it has to have the 90-degree angle. That tells you it's a right angle. Sides A and B are technically called the legs of the triangle. And side C is the longest side. Does anybody remember the fancy word for it? Hypotenuse. That's what you're going to say? So the hypotenuse is always the longest side. And you should have enough common sense to look at a picture and be like, that's clearly the longest side. But sometimes they're a little tricky. So if you're ever not sure which one's the longest, because it might be like an isosceles triangle where two sides are like the same and it's just throwing you off, it's always opposite of the 90-degree angle. So it's always the side that's not creating the 90-degree angle. It's always the opposite of that. And then does anybody know the formula for it? Plus B2 equals what? C2. So A squared plus B squared equals C squared. C has to be the hypotenuse. A and B do not matter. They go back and forth. So whatever you want to choose for A, whatever you want to choose for B, it doesn't matter as long as C is the hypotenuse. So for number 1, just looking at your triangle, is 8, 13, or X my C? X. So let's put a C here. A and B literally do not matter. So which one do you want to make A? Sure. So A, B. If you switch them, you get the same answer. So we're going to plug it into the formula. So A is 8 squared plus B squared is 13 equals C squared, which is, you could put a C there. I'm going to put an X. It doesn't matter. Do we remember doing this? Okay. So now we're going to simplify. So 8 to the power of 2, if you do not know where your power button is in your calculator, I'm about to show you. So we're doing 8 to the power 2. You should know this off the top of your brain, but 64. If you don't know, this button right here, X squared, will make it go to the power of 2, which is 64. What about 13 squared? 13 squared is 169. We're gonna sneeze. What should I do now? Good. 233 equals X squared. And now how do we get rid of the square? Go. Everybody's been saying that all day. You square root it. So squaring makes it bigger, like 8 squared is 64. If I square root 64, it goes back to 8. So it's literally the opposite of squaring. Squaring, square rooting, it goes back and forth. So we're going to square root. And you're probably like, where is that on my calculator? So if you look at your calculator, it's actually the same button. Mine's pink, so you can't really see it, but it's above this button. That's the square root. So I can't press this because it's going to make it huge, because then it'd be like 233 to the power 2. So I have to press shift and then X squared. So it's literally the opposite. So it's a decimal. We're going to round to the nearest 10th today, which is 1 decimal place. 15.3. Because it's 0.26, so that 6 is going to make the 2 go up to a 3. So 15.3. Easy peasy. Sure. Try number 2. Start by figuring out which side is C. C is the longest side. A and B flip-flop. It doesn't matter which one's A, which one's B. Don't stress about that. C is the only side that matters. C is along the side. C is opposite of the 90-degree angle. Some of you are going to feel like I move super slow. Or you're going to feel like you said yes. Yeah, some people are going to feel like I'm moving too fast. So they did a new thing this year, and they took geometry regular away. So there's no such thing as a geometry regular class anymore. So what they decided to do is put all the kids together in the same geometry class and call it geometry honors. So in this class, you have to keep in mind, we have level 1s, 2s, 3s, 4s, and 5s in the same class. So my 5s are gonna think that I'm really, really slow. And then my 1s are gonna think I'm really, really fast. And then my 3s are gonna be like happy in the middle. So just like kind of help each other out at the table. There is no more G or regular, so like, which kind of dumb, which is really fun. And if I go too slow for you, you can move to me, it's no big deal. Because eventually you're gonna have to do the other problems at some point. So which one's C? Good. So I'm just gonna set this up. I'm not gonna do the whole problem. So if I do 22 to the power of 2 plus 27 to the power of 2 equals x squared. Remember, A and B could flip-flop. It doesn't matter because either way you're gonna square them and add them together. So when I square them and I add them together, what's that big number I get? 12, 13. Yep. And then last step, I have to square root it. So what do you get as your final answer? What? 34.8. Because shift square root. If you got like a massive number, if you got that 12, 13, and then you didn't get your decimal, 12, 13, crap, 12, 13. People are forgetting to press shift, so then you end up with like a number like this, and you're like, what the heck? You have to square root, not shift. So like, or like square root, not square. So 34.8. Okay. We good? Okay. So number 3, same kind of process. Which one is my C? 9. Good. That's my longest side. That's my hypotenuse. That's my C. Which one do you want to call A? I heard more 7, so I'll use 7, but it doesn't matter. So I'll call that one A. So I'm going to do 7 to the power of 2 plus x squared equals 9 squared. So it looks a little different, but it's okay. We're still going to square our numbers, simplify, no work, no credit. It's math class. So what's 7 to the power of 2?
49.
Good. Plus x squared. And then what's 9 squared? 81. So this one I cannot add 49 and 81 together because they're separated. Good. So we're going to minus 49 to both sides to isolate our x. Because we know C this time. So this time we knew the hypotenuse. We technically know the answer. The hypotenuse is 9. This time we're trying to find one of the missing legs. So when you're trying to find A or B, you're going to have to subtract. If you knew A and B and you were finding C, it's super simple because you just square it and add it. But because I'm no C, I have to find the leg that's not it. Does that kind of make sense? So when I subtract those, what do I get? 32. And then it's the same last step because I got to get rid of the square, so I have to square root it. So 5.7. Okay, we're like improving. Do we feel good? You feel okay? Once again, if you got a really big number, you just forgot to press shift. So you squared 32 instead of square rooting. Try 4. You got this. I believe in you. Figure out which one's C first. There's a back and forth of the no. Because you need to point X. So you could, but then the problem is you don't have this. So you have this, like you're missing, the same. You're sort of thinking the right track, but like. Would you try number 5 already? They're kind of like one facing the harder. Yeah. But that's not X. The side. You're trying to find a way. If you're done with 4, try to think about number 5. About maybe what it would be. You're done with 4. 5 where it starts to change a little bit. Yeah, it's mostly science in one picture. No, because you're just finding that thing. You're not finding the error. That's what you see. Yeah. That's good. Wait, now I'm second guess myself. I think Char's is right. Yeah. Yours is right. Yours is slightly off. Okay, so for number 4, this one's C. A and B do not matter. So if you did x squared plus 19.1 squared equals 35 or 30.5 squared, it wouldn't matter if you switch these, but this one has to be C. So no matter what, it should be equal to 30.5 squared. This one ends up being a subtraction problem because you know the C. So you have to subtract to both sides and then you square root. So for number 4, what's your final answer? 23.8. Now if your decimal is slightly off for some reason, it may be because when you put this into the calculator, if you do 30.5, oh crap. If you do this and then you put 930.3 because you're like, I'm rounding to the 10th. And then you round the other decimal to the 10th, and then you subtract it, and then you round again when you take the square root of that. You've just rounded 3 times in one problem. So now your answer might slightly be off. So whenever you're doing these and there's only 2 decimals, you want to use that whole decimal until the very end and then round at the very end. Just because if you think about it, if you round here and then you round here and then you subtract them and then you round again, now you're off instead of by 0.1, now you're off by like 0.10 or point whatever. So then it might be throwing off your final rounding. Does that make sense? Yeah. Just be careful. Okay. Obviously, if whenever I square that, it was the whole calculator, I would not use that whole decimal because that's like obnoxious. Let's move on to a harder problem. So number 5 is triangles and triangles. Anybody think they have an idea of what we could think? No. Tell me.
So I there my face and movie with both sides of the phone. I did 11 to the power of 2 plus X.
Well, where'd you get 11? Where'd you get 11?
Not 11 from the bottom since I did 22 divided by 2 to 11.
Yes. Okay, so pause there. Pause there. Okay, so for this, what she's saying is she noticed that this triangle has this split. So it's the same triangle, just overlapping itself, flip-flopped. So instead of using the 22, because that 90-degree angle is not in the big triangle itself, it's in the small one, we could take 22 and cut it in half. So each side of this is 11 and 11. So the end goal is to find that height. So what else could we do, or what can we do from now? Dummy.
You try to find the length of the leg because it's heavier back.
Yeah, okay.
And so we do just take the previous one.
So what's my equation then that you use?
You would use like 11 squared plus x squared. That's the number 24.
Perfect. So it's the same thing, but instead of looking at the whole picture, I'm going to just like shade in one half of this. It doesn't matter what half you use because it's the same triangle, whether you look to the left or to the right. But instead of using the whole base of 22, now it's just 11, and then my height is x. So if you need, like, you can physically, like, literally cover up a side. But from that mini triangle, C is the 24 that you're using. So take a second to solve if you haven't already done so, which most of you haven't. That's fine. Now that we've done a couple problems, so you remember they're doing this in middle school? Yeah. Kind of.
My son is doing a weird teacher.
You had a weird teacher?
I wasn't at Largo Middle, I was at Plano. It's,
Oh. Sorry.
you know.
That is no idea.
What'd you get?
For what? Number 7.
Oh, number 7? Oh, come on. That's my answer. This is our last paper. What'd you get?
33.6. I got rounded.
Yeah, so that's the only thing, but like, that's fine, that you were like thinking in the right path. Did you do the small triangle, then the big triangle, and then added them together, or did you just use the big triangle? Did you small and added them? That's correct, yeah, we're good. Cause I got, 33.2, you got 33.6?
Yeah.
Yeah, that's fine. Fifth period of community class. All
13 more.
right, yeah. What'd you get? Okay, so for this one, what do we got? 21.3, good. Let's look at number 6. Yeah. Huh? For number 6? No. Yeah, you keep going on your own things. Let people think. Okay, so for number 6, we don't have a right triangle. We have a trapezoid. We have to make a right triangle. Okay, so we have a trapezoid, which now you're trying to visualize a trapezoid. That's a trapezoid. We need a right triangle to use the Pythagorean theorem. Does anybody see where I can maybe draw a line to make a right triangle?
Between,
The 18
Yeah,
and down.
and down. Okay, so if I go straight down from right here, I can like, and then voila, now we have a triangle. We have a rectangle too. So we just made our trapezoid into a rectangle and a triangle. This is technically a right angle because if I draw in a straight line going straight up to make a rectangle, that's 90 degrees on both sides of the rectangle. So now I have my triangle that I can use a Pythagorean theorem for. We know rectangles have congruent sides. No, lengths can't be negative. So in geometry, a lot of your answers, like x can be technically negative, not in the Pythagorean theorem though, because it's representing a side. But as we get into like actual geometry, you're never actually going to have like a negative answer, final answer, because it always represents some space. Okay, so if the bottom is 5, where else can 5 go in my rectangle? At the top, right? And then if x is on the side, x can go here because we know rectangles from elementary school have congruent sides. So what numbers am I going to have to use for the Pythagorean theorem for my right triangle? Okay, so I have 16, I have x, but I can't use 18 because 18 represents this entire length.
13.
So it's going to be 13. So 13 represents that distance, 18 represents the whole distance, 5 is that little piece. Is it making sense in your brain? From your right triangle across from your 90 degree, that's your C. So we are not using the 18. We are not using the 5. We are using 13, x, and 16 for the Pythagorean theorem. So take a second, write your equation, set up your Pythagorean theorem. Only the numbers on the right triangle. Just because there's a 5 in the problem does not mean we have to use 5 in the Pythagorean theorem. Yeah. You got it? What did you get?
55.
For which one? Number 6? No, number 6 is not right. You added them. I think that's what you did. 16 should be your C. So it should be 16 squared is what it's equal to. Did you do 13 squared plus 16 squared? No? Yes. Correct. Yeah, it's here. So this is that. So X is the same line.
Yeah, no. I got my phone. I'm trying to find it.
You're not finding area. If you were finding area, that's yes, that would be, so that's a whole nother step.
Yeah.
Good. Okay, we're doing good. I got none. Good. That's correct. That's correct. Yeah. Okay, we are going to jump across. So we're jumping around. Let's go to number 9. Jump around. So it's kind of similar. Jump to number 9. We're not doing 7. We're also not doing 8. We don't have I don't need to we don't need to do a million problems. Okay, so number 9, take a second, look at what you got. The nice thing is it's still a trapezoid, but they drew in those lines. So now you have triangles at least. Take a second and think about what you could do to try to find X. I'll give you like a minute. See if you can figure out something. Geometry, math isn't terribly hard, so more like. Yeah, that's right. Really. Okay, we got one person that's figured it out. Well, in the process, but there are other numbers. Think about the numbers that are given. Where maybe you've been.
Yeah, we.
Yeah. No.
That's all I.
There's 20s. Someone's by 20.
Wait, let's go. It's bad, but just comparing it,
No, not like 22. Like 20.
No. I just I'm not saying that I would do that, but it's like transparency is ugly. Drink is the best.
You can just split that and make it 7. Where'd you get that?
It's music.
From the 40? You were like, I'm gonna split it. No, you can't do that.
Really.
Good job. That's right.
Yeah.
Max. Oh, you're on the right track. Good job. Okay, let's talk about it. So, if you have this crazy thing, okay.
Would you split 40?
Okay, so this is what people are trying to do. They're like, well, if this whole thing is 40, I'm just gonna split it into 4. So I'm gonna say this part's 10, this part's 10, this part's 10, and this part's 10 to make 20 in the middle. But that's not 20 in the middle. How much was that in the middle? 26. So if this top piece is 26 and this bottom piece is 26. So it's not 20, it's 26. So how much is left over if the whole distance is good? So the whole thing is 40. The middle piece has to be 26 because it's got to match the top. So you have 14 left over, but there's 2 triangles on each side. So 7. 7 plus 26 plus 7 makes 40. Yes. No. Okay, we need to find X. So which right triangle should I use? To the left or to the right?
The right.
Technically, it doesn't matter because they're the same. So if I use the right side, X is over here. So now X is over here. So now just looking at your triangle, you can do the Pythagorean theorem. You have 7, you have X as A and B. C is going to be 20. So if you haven't done so yet, take a second, write out your equation, solve it. So you're using just this right triangle. What's up? Huh? Where'd you go? That's correct.
But if we both are, we're both doing it, so we can go back and do it.
Okay, so what do we get? Yeah.
So.
18.7. 18.7.
Oh, yes, he's better.
Okay, we're gonna do one word problem. I know you guys love those. They're your favorites. Mine too. Okay, so let's do one word problem. So this one's 18.7 that you should have got. Let's do number 10 because it's directly underneath it. So 10 says a roofer leaned a 16-foot ladder against a house. If the base of the ladder is 5 feet from the house, how high up on the house does the ladder reach? And you're like, great, words. Okay. So you have to think you have a right triangle somewhere in this picture. We're talking about a house. So I'm going to draw a cute little house. Here's my house. Yeah. The ladder, does it go, when you climb a ladder, does it go straight up vertical up against the house, or is it tilted a little bit? It's tilted because if you went straight up, you just fall backwards. So we have to have our ladder slightly tilted off. 16 is going to be C because that is the length of the ladder. A 16-foot ladder is here. It's leaning up against the house. So the ladder is leaning, that's my C. What other number do I have?
5 feet.
Well, yeah, but like where would it go? Technically, the bottom because it's the base. It says the base of the ladder is 5 feet from the base of the house or whatever. So here's your right triangle. It's being formed by the house. You need to find out how high up on the house your ladder reaches, which means how tall is it over here? So C is your ladder because it's across from your 90 degrees. Remember, 5 and X can flip flop. It doesn't matter as long as 16 is your C. So what do we get? 15. That's correct. How do we feel? So good? Okay. So you are going to, you don't have to complete the problems on the front. We're done with the front. Don't scribble them all out just because we may go back to this. Probably not. But still, don't scribble anything out on the front. On the back is your, you have like 10 minutes. You can do this in class. Some of you will finish it before you leave, which is totally fine. On the back is your homework, which you're going to turn in on Canvas because I have to use Canvas this year. You don't have to do number 7. So you can put a little X next to that. You have 10 minutes. You can get through a good portion of these before you leave, if not all of them. This is what I mean. I don't give you like a separate homework assignment. You can just work on them now. Use as much time as you need. And then whatever you don't finish becomes your homework, which you'll turn in on Canvas. Let me know if you get stuck, if you need help. No work, no credit. So whatever you're plugging into the calculator, write it down. Yeah, skip 7 on the back. Unless you want to challenge yourself, then you can try it. And I'll let you know if it's right or wrong.